Hello, today we're going to be going through two very difficult GCSE questions. I hope you enjoyed this video. Okay, so in this question, we have a regular hexagon, A, B, C, D, E, F, this smaller one, is inside an enlarged hexagon by scale factor P of F, G, H, I, J, K. And we are asked to find the shaded area. How we can find it is by first finding the area of this large hexagon and subtracting it from the area of the smaller hexagon, as that will leave us with just the shaded area. So let's go about finding the area of the smaller hexagon first. It doesn't make a difference whichever one you find, but I'll just choose the smaller one. It has side lengths of x, as we are told. Now, how can we find the area of this? Well, an easier way would be, rather than trying to find the whole area at once, is we split this up into a rectangle and two smaller triangles. So these triangles are going to have the same area. So we just need to find one of them and double it. First, let's try and find the area of triangle ABF. So we have ABF. It has side lengths of x and x. We don't know this length. But what else we can find now is, as it's a regular hexagon, its interior angles are going to add up to 720. So if we do 720 divided by how many corners are there? 6, 120. So now we know this angle is 120. So how can we find the area of this triangle? Well, we have the formula half AB sine C. And we have A as x, B as x as well, and C as 120. So putting this into our formula, we're going to get the area of triangle ABF to be a half times x times sine of the angle, which is 120. And sine of 120 is just root 3 over 2. So we're going to get the area of this triangle as equal to root 3 over 2 multiplied by a half, so root 3 over 4, then x squared. But we want both those triangles' area, so we just double this to get both the triangles. That is root 3 over 2x squared. So now we found these two areas. All we have left is the area of this rectangle. So let's draw out this rectangle. So we are given that its width is x. However, we don't know the height, but we can find that. If we look at here, we'll have a right angle triangle. Using trigonometry, we'll be able to find this length, and to find the whole height, we'll just double it. So let's draw this triangle out smaller here. CD, it has a hypotenuse of x, and again, we said the angles are going to be 120. However, we have half of the angle, so they're going to be 60. So now, what length do we want to find? This. So we'll call this n. So how will we find n? I'll write down our formula first, trigonometry. So we have the hypotenuse, and we also have both the other angles. So we can choose either of these equations. I'll just choose SOH for this example, but it doesn't make a difference. So we have sine of 60 is equal to the opposite, which is n, over the hypotenuse, which is x. So n is going to be sine 60 multiplied by x. As sine 60 is root 3 over 2, n will be root 3 over 2x. But remember, we said that the length of this is going to be twice this. So we just multiply this by 2, and we get here as root 3x, the length. So now we can find the area of this rectangle as well, which is going to be root 3x multiplied by x. So the area is root 3x squared. So now let's just get rid of this. So we can find the area of this whole hexagon now by just adding up root 3x squared and root 3 over 2x squared. Root 3 plus root 3 over 2x squared This is going to be equal to, we'll take x squared out as a factor. Then we have root 3 plus root 3 over 2, which is just 3 root 3 over 2. So now we found the area of this smaller hexagon. And we have the larger hexagon, which is being enlarged by scale factor p. Okay, so our linear scale factor is p. And when we have a scale factor of length, we also have a scale factor of area. The area is not going to be p times bigger, it's going to be p squared times bigger. So to get from this area to this area, we need to multiply by p squared. So the area of the larger hexagon is going to be the area of the smaller hexagon multiplied by p squared. So now we have the area for both of these. And remember, how are we going to find this shaded area is just subtract them. So we have 3 root 3 over 2 p squared, lots of x squared, take away 3 root 3 over 2, lots of x squared. Now we can do some factorizing, so we can take out 3 root 3 over 2 as a factor. And we're left with p squared x squared minus x squared. And we can finally take out x squared as a factor. So we're left with p squared minus just 1, lots of x squared, which is just what we are aiming for. And that's the final answer. Now, before we move on to the next question, I have an announcement to make. So I am starting an online tutoring for anyone who wants a tutor during this exam season to help them try and improve and be able to get the grades they want. So if you want more information, just look in the description down below and we can try and get it sorted out. Enjoy the rest of this video. That previous question was very tough. Now we also have another difficult question. Here we have a circle with center minus 1, 3, and there's the point A, which has the coordinates of 6, 8, and lies on the circle. So first of all, let's just draw a very rough diagram to get an idea of what's going on. So we have the center of a circle at minus 1, 3, somewhere around here. Now this does not have to be accurate whatsoever, it's just so we can get an idea. And we have coordinates A, 6, 8. And we are told to find the equation of the tangent to the circle at A. So the tangent is going to look something like this. It's going to go across at A. Now here we can use circle theorems. We know that a tangent and a radius of a circle will always meet at a right angle. So the gradient of the tangent is going to be perpendicular to the gradient of the radius to A. So what we can do is find the gradient of the center of the circle, minus 1, 3, to A. How do we find the gradient? It's the change in y, 8 minus 3, over the change in x, 6 minus 1, which is going to be 5 over 7. We're going to find the gradient of the tangent, which is going to be perpendicular to that. So it's going to be the negative reciprocal. So we put a minus and flip the fraction. So it's minus 7 over 5. Now we have an equation of a line. Y equals minus 7 over 5x plus c. All we need to do is find c. How can we find it? Well, we know the point A will be on the tangent. So we can just substitute the coordinates of A into this equation. So put in 8 as y and x as 6. We have this. We can rearrange to find c. 8 plus 7 over 5 lots of 6 is equal to c. So we have 8 plus 42 over 5 is equal to c. We can simplify this. 40 over 5 plus 42 over 5 is equal to c. So c is going to be 82 over 5. So now we have the equation, which is y equals minus 7 over 5x plus 82 over 5. However, we're not done yet, as it wants us to give it in a specific form. So we just got to make everything on one side of the equation. So we just add, we can multiply everything by 5 first. 5y is equal to minus 7x plus 82. Now we can add on 7x to both sides. and take away 82. And this is going to be our final answer. Thank you guys if you made it this far in the video. I hope you enjoyed and you learned something from this. Goodbye.